Okay, welcome to part two of the video. This time we're going to look at problems 6 through 10. The last video were the first 5 problems, and the next this video we'll look at problems 6 through 10, which we also talked about in class, well, most of our classes. So, problem number 6. Determine the solutions to the equation x squared plus 15x plus 54x. So I wrote it right here. Equals to 0. It is very easy to solve an equation, a quadratic equation, especially if it's set equal to 0. Because all you need to do is just simply graph it and trace it and find its zeros. So talk about that a little later. So if I graph this equation in a graphing calculator, use the graph trace to get the zeros. The zeros are the solutions. Get solutions to this equation. If x is equal to -9, you get a 0. If x is equal to -6, you will get this equation will be true. So just so you can see quickly again, to see it again how we use the graph trace, I'll go ahead and pull this up on the calculator. Let's see, and it's like I still got stuff going on here. All right, let's go ahead and minimize that. All right, brand document. Let's go with a brand new document. Okay, I don't want to save anything. Let's see, get rid of all this other stuff. Okay, no. All right, there. Brand new calculator. Let's go to graphs and let's graph. Notice that I'm just going to put in the x squared plus 15, I believe it was 15x plus 54. Press enter. All right, and there. Okay, and let's just make sure I got this right. I just want to make sure I got the right. Yeah, 15x plus 54. That's good. All right, so what are the zeros? Okay, what are the zeros? Well, all we need to do is do a graph trace. Menu, trace, graph trace. I'm just using my right and left. So if I go down to, I keep going down until I get to the zeros. This thing showed it start off along, it starts at the y-intercept. There. So I got a 0 at -6. And, let me go back. There's a 0 at -9. Matter of fact, I can mark those by pressing enter. If I press enter, it'll drop a point right there. And then if I trace and go to the other 0, go back down. And if I press enter, it'll drop the point there so I can see both zeros at the same time. So those are my two zeros for the graph. So if I'm trying to solve the equation, x squared plus 15x plus 54 equal to 0, then x could be two numbers. X can either be -6 or it could be -9, and that would be true. So which choice is that? C. And we solved it with graphing. Now there is also another way you can solve it. The calculator can solve this directly with the polyroots function. And I'll go ahead and show that as well. So let's go back to the calculator. And this time we'll go to the calculator page. Let's go to calculator. And I'm going to press menu, 3, 3, 2, and there's polyroots. Now, since it's a root, we already know that this equation is assumed to be equal to 0. So all I got to put is x squared plus 15x plus 54. And because I'm looking for a root, calculator automatically knows that this is supposed to be set equal to 0. So all I'm going to do is put a plus, tell the calculator to look for x, and there it tells me what my two solutions are. Notice this is not an ordered pair. X can be -9 or -6, and those are the roots of that trinomial. Okay, all right. So that's another way in which you can solve that problem. Okay, let's look at let's go to number 7. Well, problem number 7 says which of the following has a parabola that has an axis of symmetry at x equals 3, a vertex at 3, 2, and a range is all numbers less than or equal to 2. My answer to this problem, just graph all 4 and see which one of them works. Okay, let's see which one has which of these have an axis of symmetry at x equals 3. So if you graph these, and I'm assuming that you know how to graph at this point, just look at the graph. Okay, so let's graph one of these. Let's look at the graph one of those. I think I'll take this one and make it larger. Okay, move that one out the way. If I graph A, look at the graph of A. If I graph A, I'll see that it does have a vertex of 3, 2. I see that it has a vertex of 3, 2. If you look carefully, you might be able to see why it has a vertex of 3, 2. And then because, and the axis of symmetry which goes through the vertex is this line right here. Well, that's clearly that's definitely x equals to 3. So far it's looking pretty good. But if I look at the range, remember the range is the y values in the function. If I look at the y values in this function, the lowest, this is a minimum. The vertex is at a minimum, and the minimum y value is 2. So the y values start from here, and then they go that way. Well, that's y greater than equal to 2. That's what the range is. But we want the range to be all real numbers less than or equal to 2, which is not this. So that means this one is not the answer. So we can discard this one. If we look at the others, let's see, I'll just put that one away. Let's look at B. Well, let's see, B. I think this one is B right here. Let's look at B. And remember, it has to meet all 3 conditions, okay? So the first thing we need is the vertex needs to be at, well, let's see. Let's look at the problem again. It's got to have an axis of symmetry at x equals to 3. Well, 3 is over here. So this is axis of symmetry. That's x equals to -3. So we already know that one doesn't work because it doesn't even have the right line of symmetry. So we'll take this one away as well. Let's see. Go away. Try to make it go away. You don't want to go away. All right. Now the other ones went away fine. Let's see. There we go. All right. All right. Let's look at choice C. I believe that's choice C. All right. Again, I'm assuming that you graph this, that you know how to graph this. In other words, just open a graph tool and just type the function in. Now, if you look at this, we have the same problem with this that we had with choice B. The line of symmetry is at -3. We needed the line of symmetry to be at x equals 3. So we don't even need to get started with this one. So this means by default, because all the rest of them didn't work. Let's see. I'll just move that. Come on, move. Go. All right. So that means that this is the last choice. This must be the one that works. If I can just get it to pull. Let's see. You know what I'm going to do? I'm just going to delete that one. All right. And I'm going to delete. Is this the one I want? Yes. All right. So let's look at this last one here. Yeah, that's the one. Let's see if it meets the condition. Okay. All right. So if I look at this last graph here, it has to have an axis of symmetry at x equals to -3. And there it is. X equals to 3. That's the line of symmetry. The vertex is at 3, 2. There's 3, 2. And the range is all real numbers less than, let's draw the range of this graph. Its highest point is 2, and it goes down from there. That's y less than or equal to 2. So this graph meets all the qualifications of number 7. So the correct answer choice is D. All right? D. D is our choice. Okay, now it works fine. So D is our choice. Let's go to 8. All right. Now, let's see. We'll get to the solution 2 in a minute. Matter of fact, I'm just going to kind of cover that up so it won't distract you. All right, look at number 8. Football is kicked from a starting height of 3 feet with an initial upward velocity of 40 feet per second. Use the vertical motion formula, h of t equals to negative 16t squared plus 40t plus 3, where h is equal to height and t is equal to time to land. At what times is the ball at 20 feet in the air? Can you spell graph trace? That's what I would do with this. And there are many, many ways to solve this. But I'm just going to go, basically our approach is, let's graph this football, the height of this path of this football. We won't use t, we'll use x. We'll graph it, and then let's just pick out on a graph using graph trace, where is this graph equal to 20? Okay, so let's just do that. And this is basically in a nutshell what we'll be doing. We'll graph it, get this graph, and we'll just use graph trace to get this point right here. And that'll tell us that since t is the time, x is the time, and y is the height, so we want to know what is, when the height is 20, what is the time? And the time is just over a half. So here are our steps again. Graph, trace, which is menu 651, and we're going to do something extra. We're going to press enter to place a point on the graph like we did a few problems ago. And then we're going to do something else. We're going to actually change these values so it can say exactly what we want to say. So let me show you what that looks like. All right, so let's go to the home screen. Let's do a graph. And let's put in that function. I believe it was 16x squared plus, now I actually don't remember the rest of it just that quick. Let's see. All right, here we go. All right, it was plus 40t, well, 40x now, plus 3. All right, so let's go ahead and graph that. And you know, it's all off the page and everything. So let's go ahead and see if we can see the top of this graph. So I'm going to take my maximum y, and I'm going to make it at least, let's see, I'm going to make it, it says, I'm going to make it at least, well, I need to see when it's 20 feet up in the air. So let's see what happens if I make this thing go up to 25 feet. Okay, I can actually expand it. Let's make it 30 feet. All right, that just enabled us to see the top of the graph. Be nicer though if we gave us, if we didn't have all this extra real estate here. So I'm going to go ahead and double click on a 10, and I'm going to make it a 5. Okay, now I got all this extra space I don't need. I don't need all this dead space. So I'm going to make this 10 over here a -1. Yeah, that's nice. And I'm going to take this, and that's because I'm particular. I'm going to go ahead and make that a 1. All right. So there we got a nice little graph there. All right. So all we need to do is use graph trace on this. When is the football 20 feet up in the air? We know it's 30-something feet up in the air past 1 second. So that kind of gives us an idea. But let's do graph trace. Menu, 5, 1, and let's just get to tracing. Okay. All right. Oh, there's my maximum. My maximum tells me that the football is 28 feet up in the air when at 1.25 seconds. 1.25 seconds, the football is 28 feet in the air. So, but I want to find out when is it 20 feet in the air. So let's go down. And as you can see, if you do your trace, it won't stop at 20. But there's a way that we can make it stop at 20. All I got to do is take my, first of all, I need to press enter. If I press enter, it's going to drop a point where I'm at. All right. And then once I got that point, I can escape the trace. And now I can use this point to do the rest of the trace. So I'm going to double click on the 13.6, put a 20 there, and find out when the ball is at 20 feet. And it's at 0.543. And if I look at my answer choices, that is obviously choice C. And if I want to just for yucks, I want to check out that other choice. What if I made the time, it says T 1.96. I got to double check that. 1.96. And if I do that, 1.96, that's almost 22. So I just thought I'd just double check that. All right. So that's a real easy way to solve the equation. And what we're actually doing is solving this. We're solving the equation 16x squared plus 40x plus 3. When is that equal to 20? And that's basically what we're doing. It is equal to 20 when x is equal to either 1.96 or, if I can get that, I probably can't get it exactly. It's pretty doggone close. Yeah, ooh, I had it. I almost had it. Well, if I double click this and make that a 20, be exact. So that's one of the solutions there. And notice it's at 20 in two different places. Okay? All right. So there is another way to do the same problem using the intersect tool. And you can do that as well. Menu, analyze graph, intersection. We don't have the other graph in there. Kill that. Let's put the other graph in there. Just press tab and put 20 in there and there. And just get the intersection there. So if I do menu, analyze graph, intersection, and then just tell the calculator to look between here and there, it'll give me the intersection. So there's another way to do that. So there, it's all sorts of ways. Let's see, that was problem number 8. There's a domain and range problem there. And let's quickly do 9 and 10. Let's see where we are on the time on this. Okay, oops. All right, I'm gonna stop this video and then we'll pick up with 9 and 10 on the next one.